Hi everybody, I just thought I'll make a short video about the introduction to AC so that you can go back and review it once more. So this is the lesson that we had yesterday, but this is just a synopsis of the lesson. So first of all, a generator, when you have your coil spinning in a magnetic field, what it generates is an alternating voltage. And the shape of this graph of voltage against time looks like this. It's like a sine curve. So this is your voltage against time, and there's your alternating voltage. Now the thing with the alternating current is because it's going back and forth, the electrons are actually moving back and forth in simple harmonic motion. This can be represented, the voltage at any instant of time is given by V equals V max sine omega t. Now what is V max? This point at which it peaks, that is called the maximum voltage, or it's also called the peak voltage. And how do you get maximum voltage? It's possible to calculate maximum voltage using this formula. V max is BAN omega. So what do all these letters stand for? The letter B stands for magnetic flux or magnetic field strength. A is the area of the coil, and N is the number of turns of the coil, and omega is your angular frequency, how quickly is it spinning, okay? And if you have an AC supply, so an AC supply voltage is represented by this, so that's your supply voltage, but it's AC, and your circuit is complete such that it's passing through wires, through a resistor. So if you have a resistor as well in the circuit, then you have a current. Okay, so whenever you have a potential difference and a circuit is complete, you have a current. And if you draw a graph of current against voltage, you end up with, again, a similar sort of sinusoidal graph. So it's a sine curve. So the maximum current at any instant of time, this is called I max or I peak. Okay, it has both those. And so the equation for the current at any instant of time is similar to your voltage. So current is given by I max sine omega t. Now you notice the letter omega figures quite prominently in AC because the thing is going back and forth, or the coil is spinning. So how do you get this omega depends on the frequency, and omega is given by 2 pi f. So frequency is an important thing about AC. Now, if you look at both these graphs, if you're trying to calculate average voltage or average current, because there's the same amount above and below the x-axis, the averages actually come out to be 0. That doesn't mean there's no voltage or current in an AC circuit. There's another way of averaging this out, and that is where we use power, because power is voltage against time. So now these two graphs coincide. So if you're trying to draw a graph of power against time, what actually happens is 0 times 0 will be 0. A positive times positive will be a bigger positive number. 0 times 0 is 0. But if you have the negative times the negative number, 2 negatives always gives you a positive. Okay? So power is actually never a negative value. It is always a positive value. So the graph of power against time will look like this. Okay? And where it peaks is called your peak power. And your average power, it's like dividing this whole thing into 2, so there's an equal amount above and below the x-axis. Your average power is actually peak power. So in class, what I did was I did a phasor to get values for the different parts of this by using V equals V max sine omega t. And once you know those values, it's possible to calculate I if you know the value of that resistor. Okay? So, and this is the concept that we use to calculate our root mean square values. So I'm in school, teachers are just arriving, so the sound of someone in a bike. So let's just look at the root mean square value. So the root mean square value is the equivalent DC value which gives the same power output or which has the same heating effect. So RMS value stands for root mean square values. That's what this stands for. Okay? So for a DC supply, which is a steady supply, your power is voltage multiplied by time. Okay, that's how you get power. And if you substitute for V or I using Ohm's law, you get the heating effect is actually I squared over R, I squared times R. That's what this works out to. For an AC supply, your average power is equal to half peak power or maximum power. Okay? Now your average power is V times I, and that's equal to half V times I, but we've got to put something here. So your average power is V RMS times I RMS is equal to half V peak times I peak. Okay? Now in substituting V times I equal to I squared R, because I need to find an expression for V and I need to find an expression for I. So if they're both there, it's hard to find because there's two unknowns. Okay, so this is the same as writing I RMS squared R equals I peak squared R. Now if you look in both these, R is a common factor for both these. So you end up with I RMS squared equals half I peak squared. So if I square root both sides, I end up with I RMS is equal to I peak divided by square root 2. And that is how you get the RMS value if you've given the peak value, or if you know the peak value, you multiply by square root 2 to get the RMS value. So for the voltage as well, you have a similar equation. So V RMS is equal to V peak divided by square root 2. So that's how you get your RMS and peak values for an AC supply. Now, one thing to remember is in calculations, we don't mix the two up, RMS and peak values. If you're using Ohm's law, then if you're using RMS values, your V and I both have to be RMS. If you're using peak values, both your V and I have to be peak values. Okay? The other important thing to remember is whenever you have to calculate power, you always use RMS values. You never use peak values. So power is always calculated using RMS values. So I hope that makes sense, and that was your first lesson on AC. So bye for now and enjoy the rest of your day.